Okay, today we're going to look at section 3.9, scientific notation. When we say that a number is in the scientific notation, we are specifying the form in which that number is written. That form begins with an integer with an absolute value between 1 and 9, then perhaps followed by a decimal point and then some more digits. This is then multiplied by 10 raised to some power. So, which of the following numbers are in scientific notation? If the number is not in scientific notation, explain why it's not. Okay, so first we have 42.62 times 10 to the 13th. What's wrong is this is not between 1 and 9. No, 42 is not between 1 and 9 inclusively. About 7.113 times 10 to the negative 2. This is scientific notation. And how about negative 80.91? No, or negative 80 is not between 1 and 9. And not multiplied by a power of 10. Recall that multiplying a number by 10 adds a 0 to the end of the number or moves the decimal place one place to the right. And if you multiply by 100, it adds 2 zeros to the end of the number or moves the decimal place 2 places to the right, and so on. Similarly, when we divide by 10, we move the decimal 1 place to the left, 100 2 places to the left, and so on. Using this information, we can demonstrate how to convert from a number in the standard form into scientific form. The number is a single-digit integer. In this case, the scientific notation form of the number is the digit times 10 to the first. The absolute value of the number is less than 1. You would follow the process below. Count the number of zeros between the decimal and the first non-zero digit. Label this n. Starting with the first non-zero digit of the number, write the digits. The number was negative, include the negative sign. If there's more than one digit, place a decimal after the first digit from step 2, then multiply the number from step 3 by 10 to the n plus 1. If the absolute value of the number is 10 or larger, follow this process. Count the number of digits that are to the left of the decimal place. Label that n. Write the digits of the number without the decimal place if one was present. If the number was negative, include the negative sign. If there's more than one digit, place the decimal point after the first digit. Multiply the number from step 3 by 10 to the n minus 1. So let's write the following numbers in scientific notation. Okay, now I have negative 38,300, absolute value of 38,300, which is greater than 10. So count the number of digits that are left of the decimal point. Well, the decimal point would be here. So that means that n equals 5. Okay, write the digits of the number without the decimal place if one is present. If the number is negative, include the negative sign. So we have 38300. Place the decimal point after the first digit, right here. And then multiply by 10 to the n minus 1. So 10 to the 5 minus 1, 4. Okay, here we're going the other way. Count the number of zeros between the decimal and the first non-zero digit. There's 2. N equals 2. Now rewrite the number. 45, no negative sign. Place the decimal after the first digit, so 4.5 times 10 to the n plus 1, 3. Okay, 1, well, this is simply first case times 10 to the 0. So let's change 46.113 times 10 to the 8 by moving the decimal place. Decimal 4 places to the left. 4 places to the left. I think that's supposed to be 1 place to the left. So this becomes 4.6113 times 10 to the ninth, 1 plus 8. Move it 2 places to the left, we get 1.4911. We moved it left 2, so this is 10 to the negative 4 plus 2, or negative 2. Convert the following into standard form. So we're going to move our decimal place 6 places to the right. 1, 2, 3, 4, 5, 6. There we go. Here we're going to move our decimal place 3 places to the left. 1, 2, 3. Fill it in with zeros. So we have 00409. Okay, to add or subtract numbers in scientific notation, the numbers first need to have the same exponent for the tens. It is only possible to add if the powers of 10 match. Simply add or subtract the number parts. So in this case, note our powers of 10 are the same. So to add, we simply take 7.57 plus 2.031, and we get 9.031. That's not right. Something went wrong in my calculator. Let's try that again. 7.57 plus 2.031 equals 9.601 times 10 to the 13th. All right, here we have the same power of 10, so we have 3.03 minus 1.5 equals 1.53 times 10 to the negative 6. Adding and subtracting in scientific notation is straightforward when the exponents are the same. There are 2 issues that can arise. First issue is what to do if after adding or subtracting the result is not in scientific notation. So here we have 5.08 times 10 to the third plus 6.9 times 10 to the third, which would end up being 11.98 times 10 to the third. So that's not scientific notation, but if I move my decimal place 1 place to the left, and then simply add 1 to my exponent, and now I have scientific notation. Likewise here, I end up with 0.207 times 10 to the negative 38. Now I need to move this to the right one. So here we're going to subtract 1, and we'll have 2.07 times 10 to the negative 39. The second issue that might be encountered when adding or subtracting is that the powers of 10 do not match. In that case, one of the numbers must be changed so the power of 10s match. The steps to take when exponents of 10s are not equal. Increase the smaller exponent to equal the larger exponent. Label the amount increased as n. For the number with the small power of 10, move the decimal point of the number part to the left in places. Perform the addition or subtraction. If the result is not in scientific notation, adjust the number to be in scientific notation. So now I have 1.14 times 10 to the negative 43rd. And I have 2.56 times 10 to the negative 46. I need that to be negative 43. So in this case, the number with the small power of 10, move the decimal point in places. N is equal to 3. So we move the decimal point in places left. So 1, 2, 3, 0, 0, 0.00. So now I have 1.14 times 10 and negative 43, plus 0.00256 times 10 to the negative 43. If I add that up, I get 1.14256 times 10 to the negative 43. Okay, here we go. Calculate the following. So now my lower one needs to go up by 2. So n is 2. So I move it left 1, 2, and I have 0.0723 times 10 to the 28th. I have 9.15 times 10 to the 28th. So I subtract 9.15 minus 0.0723, and I get 9.0777 times 10 to the 28th power. Okay, next up, we're going to multiplying. To multiply numbers in scientific notation, multiply the number parts and add the exponents of the tens. The resulting answer from step 1 times 10 raised to the answer from step 2. If the number is not a scientific notation, adjust accordingly. So here I take 2.29 times 3 and times 10 to the 3 plus 4. So 2.29 times 3 is 6.87 times 10 to the 7th. Okay, here I have 6.91 times 9.1 times 10 to the negative 3 plus 5. So 6.91 times 9.1, that gives me 62.881. And negative 3 plus 5 gives me 10 to the second. I need to move it 1 to the left, so it becomes 6.2881, and we add 1 to the exponent. To divide two numbers that are in scientific notation, divide the number parts, subtract the exponent of the denominator from the exponent of the numerator. The answer is the result from step 1 times 10 raised the result from step 2. And of course, if the number is not in scientific notation, adjust it appropriately. So here I have 3.6 divided by 1.5 times 10 to the negative 2 minus 3. So 3.6 divided by 1.5 gives me 2.4 times 10. Negative 2 minus 3 is negative 5. Okay, here I have 1.8 divided by 4.8 times 10 to the fourth minus 3. 1.8 divided by 4.8 equals 0.375. This becomes times 10 to the first, 4 minus 3. Now I'm going to move it 1 to the left and I get 3.75. This becomes times 10 to the 0, which is 1. Okay. Earlier we saw that a single transistor in a computer chip is 0.00000014 meters, or 1.4 times 10 to the 8th meters in size, and that the diameter of an atom should be 0.2 nanometers, or 2 times 10 to the negative 10 meters in size. How much larger is the transistor than the atom? Well, we just simply take 1.14 times 10 to the negative 8 and divide it by 2 times 10 to the negative 10. So I have 1.4 divided by 2 times 10 to the negative 8, and this negative 10 becomes a positive 10. So I have 0.7 times 10 squared. We move it one place, and I have 7 times 10 to the first, which would be 70. Uh, don't know, 70 times. I think that's what it's looking for. Okay. Mercury is about 3.114 times 10 to the 7 miles from the sun. Neptune is about 2.781 times 10 to the ninth miles from the sun. How many times further is Neptune from the sun than Mercury? So, same principle. 2.781 times 10 to the ninth over 3.114 times 10 to the 7th. So I have 2.781 divided by 3.114 times 10 to the 9 minus 7. 2.781 divided by 3.114 gives me 0.8930635838 times 10 to the second. Now it doesn't say in scientific notation, so this means move our decimal place 2 places to the right and we get roughly 89.3 times as far. Okay. There are approximately 1 times 10 to the 12th grains of sand in a cubic meter. If the number of grains of sand on the Australian coastline is roughly 7.5 times 10 to the 21st grains, roughly how many cubic meters of sand is there on the Australian coastline? So again, take your larger one, 7.5 times 10 to the 21st. over 1 times 10 to the 12th. This one's rather easy. 7.5 divided by 1 is 7.5 times 10 to the 21 minus 12. 7.5 times 10 to the 9th, which would translate to 7. 1, 2, 3, 4, 5, 6, 7, 8, 9 decimal places. So we're looking at 7,500,000,000,000. No, million. 7,500,000,000 cubic meters. That's a lot of sand. Okay, next one. Humans collectively exhale approximately 6.4235 times 10 to the 12th pounds of carbon dioxide per year. There are approximately 7.647 times 10 to the 9th humans currently living on Earth. How many pounds of carbon dioxide does a single human on average exhale per year? So the total amount of carbon exhaled is 6.4235 times 10 to the 12th. Total number of humans, 7.647 times 10 to the 9th. So again, we're looking at 6.4235 over 7.647 times 10 to the 12 minus 9. So we look at our division. 6.4235 divided by 7.647 gives me 0.84 followed by 30,000,026,154 times 10 to the third. So here we would move our decimal place 3 places. We get 840.00. We'll stop there. So 840 pounds. And that completes scientific notation section.